All right. Good afternoon, guys. How are you? Can you hear me?
Yes.
Okay.
Yes.
Okay. It's okay. Let's not waste any time. Those who are not yet in the meeting, they will get their recording. But as I've said the last time, today's lesson is about arithmetic series. There's a relationship between arithmetic series and arithmetic sequence. So now, let's start with how are you able to spot out that what you are given is arithmetic sequence? So arithmetic sequence, you can be able to see that the sequence you are given is arithmetic sequence if the terms are separated by semicolons, like what we have here. Let me just write a simple sequence that we can use here, which is arithmetic sequence. So it's 2, 4, 6. That is an example of what is called arithmetic sequence. So, but now we are going to introduce another important aspect of the sequences and series, which is called arithmetic series. How are you able to see that the numbers you are given are arithmetic series? So the numbers which are given, you can be able to see that is arithmetic series if there is an addition sign in between. So you can see here we have semicolons, down here we have addition signs in between. That's the difference between the arithmetic series and the arithmetic sequence. So you should be able to distinguish that difference. It's very, very important for you to be able to spot out that. But other properties, they are exactly the same. Like the first term for arithmetic sequence is the same as the first term for arithmetic series. The common difference of the arithmetic sequence will be the same as the common difference for the series. So you must be able to spot out that. It's very important. But the general formula for arithmetic sequence, I told you the last time, that is given by a plus into n minus 1 plus d. I've given you that formula. So now, for arithmetic series, it's not the case. You don't use the same formula to find the arithmetic series terms. So we're going to use another formula, which I will introduce to you in detail of what this formula means. But for now, just take note of this, that the formula for calculating the terms on the arithmetic series is given by this formula that we have there. So now, what does arithmetic series do? And what does arithmetic sequence do? Let me explain that to you just now. Arithmetic sequence helps you to find the next term of the sequence. Let me add Takani. Okay, I was explaining the difference between arithmetic sequence and arithmetic series. If you don't understand something there, just stop me and ask me where you don't understand, so I explain that, because we are going deep into mathematics now. So now I was explaining the difference between arithmetic sequence and arithmetic series. Arithmetic sequence is separated by semicolons, and arithmetic series is separated by what? By addition. Now, what does arithmetic sequence do? Arithmetic sequence gives you the next terms. For example, let's say we want to find the 10th term or the 100th term. Then that way you're gonna use what? Arithmetic sequence. Ne? But now, arithmetic series, it does different things. What does it do? It gives you the sum of the term. Let's give an example. We say we want the sum of the next 3 terms. That you can be able to find by using a arithmetic series. It could be simple for you to get the sum of the next 3 terms, like what we have here. If a question says find the sum of the next 3 terms, you are going to add 2, 4, and 6, and you obtain a 12. Ne? It's simple to do that. But let's say a question say calculate the sum of the 100th term. It's going to be very difficult for you to do that, because you can't add 100 term for you to get the answer of the sum of 100 term. It's going to be very difficult for you to do that. Then that's where arithmetic series comes in. It helps you to find the sum of many terms. Let's say maybe for 100 term. So you can be able to find the sum of 100 term by using what is called the arithmetic series. But there's a relationship between these two, that for both of the sequences, you find the common difference. If common difference is not feasible in the sequence you are given, then you are not allowed to apply one of these methods. You are not allowed to apply the arithmetic sequence. You are not allowed to apply the arithmetic series if you are not getting the common difference. Let me understand if you are fine with what I've explained just now. Are you able to distinguish between arithmetic series and arithmetic sequence? Are you all fine with that explanation before we go deep into the mathematics of what I've explained just now? Are we together? Are you able to distinguish between arithmetic sequence and arithmetic series?
Yes.
Okay, that's good. Then now, let's go deep into the mathematics of what I've explained just now. This is term number 1, this is term number 2, that is term number 3, up to term number 4, which you can be able to represent as T1. That stands for term number 1, T2 stands for term number 2, T3 for term number 3, up to the last term, which in this case, we're gonna write it as Tn. Okay. So this is the sequence that we have there. From there, from this sequence we have here, you can be able to generate the sequence for the series. How can you go from the series, from the sequence to the series? You just have to change, instead of the semicolon, you put the positive sign, the addition sign. Then now, by doing so, you will now have what is called the series. Take note of this, it's very, very important for you to be able to understand that. Okay, after having that, we can then apply, actually what we are doing now is to derive this formula. We have that. It's very important for you to know the derivation. You are going to come across such kind of questions for deriving the formula for arithmetic series. So where we have T1, we replace by the formula we have here. So T1, you substitute the 1 there. 1 minus 1 gives you 0. 0 times D is 0. Therefore, for the first term, you can replace by what? By A. I believe you know that by now. That first term is the same as A. We did the substitution of that, but now I'm just proving to you that if you substitute 1 on this formula we have here, you're going to obtain A, which stands for the first term. Then now, if you understood how we obtained the first term, can you tell me what is going to be T2 in terms of this formula we have up there? T2 will be equal to what? Where we have T2, we can replace by what? As according to this formula that we have there. Okay, let me do T2. You will try T3. So for T2, where we have N, we want to replace by 2. And you will have 2 minus 1, which gives you 1. 1 times D is D. Therefore, for T2, you can replace by 1A plus 1D, which is the same as what? As D. That is term number 2. So you can also put this in brackets so that you know that it's where we replaced T2 with A plus D. Now, can you tell me what is going to be T3 in this regard?
Would it be A plus D?
Is A plus what?
2D.
Plus 2D, definitely. That's very true. So after having that, then you can have the other terms in between, but we can't write all of them. That's why we use the dots here. So before we have Tn, let's have Tn minus 1 plus then Tn. The previous term and then the last term, which is Tn in that case. So the previous term, how are we going to obtain the previous term? N minus 1. Where we have N, we substitute N minus 1. We will obtain N minus 1 minus 1, which is N minus 2. Therefore, Tn minus 1 is going to be A plus into N minus 2 multiplied by D plus. Then where we have Tn, we write the formula as it is, which in this case is A plus into N minus 1 multiplied by D. This we name equation number 1. If you did not understand anything on the first step we have done there, let me know, because what we have done just now is very, very important. This gives you the summation, and then the summation is indicated by letter Sn. So this is the summation of all the terms we can find from the arithmetic series. So we have first term, second term, third term, second last term, and then the last term of the sequence, which if you like, you can just put this into brackets so that you can be able to sort that out. Are we all together up to here?
Yes.
Okay, then now, as I've said, this is equation number what? It's equation number 1. Let's go to equation number 2. How are we going to get equation number 2? Equation number 2, it comes from equation number 1. What do? We just exchange the order. Instead of starting from the first term to the last term, we now start from the last term back to the first term. Remember, we want to generate this formula we have here. So you just rewrite the order of the first equation. So now, if you rewrite the order, you're going to obtain A plus into N minus 1 multiplied by D. That's your last term plus, and then the second last is going to be A plus into N minus 2 D plus. Then the other terms is this, which is A plus 2D plus into A plus D, and then the last one is A. I've just changed the order in that case. And by doing so, you will have obtained what is called equation number 2. Are you all fine with the steps I used to obtain equation number 2? You're fine, eh? If you're not, don't hesitate to let me know. I don't want us to pass this stage without making sure that you all understand what you are doing. So I just changed the order. In order for me to obtain equation number 2, I changed the order of equation number 1, and then I generate equation number 2. And the next step is for adding equation number 2 with equation number 1. We're adding equation number 2 with equation number 1. And if you do that, you will have Sn plus Sn, which gives you 2Sn. And we'll do the same on the other side. A plus A, it gives you the answer of what? Of 2A. You see that? Do you see what we have done there? So I'm just adding the terms we have from equation number 1 with equation number 2. Sn plus Sn, it gives you 2Sn. Add A with A, it gives you 2A. And then on the other one, what are we supposed to do? We add the like terms here. So now, from this, we're going to add this together with that. So when you add them together, what do you obtain? There's a relationship between these terms. This, you add it with that. This, you add it with that. This, you add it with that, like that. So now you will see that when we add these ones, we are going to obtain A plus. Then now, what do we have here? So now this D is going to multiply here, and then this multiplies here. So you will see that this and that, they're going to cancel each other, né? And you're left with what? You're left with ND. Okay, then from there, you add this with that. When you add them together, what are you going to get? Okay, this you can even write, for us not to lose this -1, we can write this as n minus 1 multiplied by d. Where is it coming from? It comes from the addition of this. Remember, A and A, we added them together already, né? And we obtained 2A. And then now we are adding this with that. This with that is going to give you A. We don't have any other A there. And then this with that, you're going to get this. Plus, you do the same there, but there's a D that we're supposed to write from there. And then plus, you do the same for this and that, and you will have A into A plus into N minus 1 multiplied by D plus. Now, you have 2D there. You see? So you are just going to increase by the D plus A plus into N minus 1 multiplied by D plus 3D plus up to the last term that you're going to obtain here. So the last term that you're going to obtain in this case is the addition between this term here with that term we have done there. Can any one of you tell me what are we going to get if we add the last terms? What are going to be the last term in this case? What are going to be the last terms here? We are adding this with that, this with that, this with that. So what do you get as the final expression there? Okay, let me do it in a simple way because I don't want to lose you on this one. So let's add this together, term by term, until we get to the last term. But you're going to get exactly the same thing I wrote there. And I just want to change the order of doing this so that it can be simpler for you. So let's add Sn and Sn. It's going to be 2Sn plus. So now here, we are adding the first term with the first term. The first term on this sequence and the first term on the second down there. So now, this is what you're supposed to add. This, you see? Let's add them together and see what we get. What do we get when we add those two? We're going to say A plus A, which gives you what? It gives you 2A plus into N minus 1 multiplied by D. Do you all see how we obtain the first term on this one?
I'm still confused.
Okay. Let me explain it in another way. Remember, the first sequence, I believe you saw how we get it. The second sequence, you just change the order. You start from the last term to the first term. So now, after having the two equations, we then add equation number 1 with equation number 2. So you add Sn with Sn, you will obtain 2Sn. And then you add A, this is the first term on the first sequence, and this is the first term on the second sequence. So when you add them together, you're going to add the like terms. So it's A plus A, which gives you 2A. But you can see this one, we just have to rewrite as it is. That's why you have it like that. So you are adding this, that which gives you this. Are we all together with that?
Yes.
Okay. If you understood that, let's add the second one and see what we have. We're adding these terms here. Do you see the terms which I'm circling? Did you see the terms I circled?
Yes.
So let's add them together and you tell me what we obtain. So it's A plus A, which gives you what?
2A.
Gives you 2A, and then you add D with N minus 2D. So it's going to be N minus 1 multiplied by D. Do you see what we are getting? K plus, and then you say dot dot. You do exactly the same thing on the last terms there. So then now on the last terms, we are going to add this term we have here together with that term we have there, this with that. So when you add them together, they must give you 2A plus into N minus 1D. It's a must that you must get exactly the same thing in this case. And then the last one is going to be 2A plus into N minus 1 times D. So now, let's put this in brackets so that you can see that what we have done here are different terms in brackets. So now from there, you should be able to observe something, that the terms you have here, first term is the same with the second term, the same with the third term, is the same with the fourth term, and it's the same with the last term. They are the same. All the terms you obtained here, they must be the same. That is underlying factor with what we are doing here. They must be the same, all these terms. So now, for us to be able to conclude about all the terms we have there, let's say it's like a sequence of having 2, 2, 2, 2. They are the same, all these terms. So if we have how many 2s? 1, 2, 3, 4. What is going to be the sum of these 2s? I'm going to apply the same principle here. You must understand what you're going to do there. So how are we going to obtain the sum of this? We can obtain the sum by adding all of them. Which when you add all of them, you're going to add what? You are going to get what? You're going to get 8 in that case. So, but now, the question is, how did you obtain this 8? The 8 you obtained by multiplying the 2 we are given, multiply by the number of terms. How many terms do we have in total here? There are 4, ne? So it's 2 times 4, which gives you what? Which gives you 8. That's very important. It's the same principle we are going to apply here. So it's the number of terms, which in this case was 8, multiplied by the number we are multiplying with. The number we are multiplying with in this case is 2A plus into N minus 1 times D. You multiply that with the number of 10. So the number of 10 from our sequence, we know is indicated by N. So it's N into 2A plus into N minus 1 multiplied by D. That is what we have. Then from there, you divide both sides by 2. So that 2 here and 2 there cancels each other. Once you simplify, you cancel 2 and 2, you're going to left with Sn. And then on the other side, you will be having exactly the formula that we are going to use to calculate the summation. This formula here is the one which is going to calculate any question that want us to get the series or the summation. Take note of this formula. It's very, very important. I've given you the full derivation of that formula. So the steps which you must remember, let me caution you about the step. I know you might not be able to take this information, the whole information at one time, but let me just caution you about a few things. Is that we generated the summation, and then we get equation number 2 by reversing the summation of question number 1, and then we added the 2 equations. We obtain what we have down there. But now we apply this principle we have here. Don't forget this principle is very important. We use this principle to obtain the equation that we have down there. And then we divide both sides in order for us to generate the formula that we are going to use in all the questions that I'm going to answer with you today. Let me know if we can now go to the questions that requires the application of arithmetic series of this formula that we have here. I believe you all remember what does A stands for, what does N stands for, and what D stands for from arithmetic sequence. You do remember, ne? Okay, let me quickly go to the example. That's where you will see that what we are doing just now is not difficult. But just keep this formula in mind, the one we have derived just now. The first question is about evaluate the sum of each arithmetic series. So now, the first one, we are given a sequence of 1, 2, 3, 4, plus ... up to term number 15. Okay, this is the question that we have there. Evaluate the sum of each arithmetic series. Without any further ado, tell me, what is this? Is it a series or a sequence? What we are given there, is it a series or a sequence? It's a series. How do we know that it's a series? Because there's addition sign in between. Are we all together? Yes, exactly. So, but now, to confirm that indeed this is arithmetic series, there is no any other way except to take the difference. So the difference you obtain by subtracting the terms, term 2 minus term 1. 2 minus 1, it gives you an answer of what? Of 1, right? And then 3 minus 2, it gives you 1. Then if you obtain the same, then this confirms to you that indeed what we are dealing with in this case is arithmetic series. Are we all together? Okay, then now the question requires us to find the sum. So sum is the addition of the terms. It's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 up to when we have term number what? Term number 15. That you can be able to do manually. Let's just do manually, and then afterwards we then compare the answer we obtain with the answer we're gonna obtain by using that formula. So we know here on this sequence we're going to have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13 plus 14. And then the last one is going to be what? Plus 16. These are the total terms we have from this sequence there. Now, your task is to add all these terms. What do you get when you add all these terms we have here? I know there's a room for making mistake if you're not using a formula. So in your calculator, you're going to say 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus up to plus 15. Tell me the answer you get when you add this using your calculator. What answer are you going to get? So just do that with your calculator. 1 plus 2 plus 3 plus 4 plus 5 plus. If your calculator is full, you can do maybe up to 8. You get the answer of that, you write it down, and then do from 9 to 15, and then you add them together. It will give you the answer that you're looking for.
120.
Okay, that's good. We get an answer of 120. That's when you are doing it manually. And you can see we did that on the sequence when we are having 15 terms. Imagine when we were having 100 terms, were we going to be able to do this? No. That's why this formula is very important, because that formula, it addresses this problem that we have there. So let's implement the formula and see if we're going to get the same answer of 120. So it's n over 2, 2a plus into n minus 1 multiplied by d. And now, how many terms do we have from 1 up to 15?
1, 2, 3, 5.
How many, from one up to 15?
Oh,
How many terms are there? This is term number 1, term number 2, term number 3, number 4, number 5, up to term number 15. How many are there?
bring it 15.
There are 15, yes, definitely. So then it means where you have n, you're going to replace by 15 over 2 into 2. What is the first term?
It's 1.
And then where you have n, you replace by 15 minus 1. And what is the common difference?
It is 1.
It's 1. Can you put this into your calculator and tell me what you obtain? In the meantime, I will be simplifying this further. So it's going to be 2 plus 14, which is 15 over 2 multiplied by 16. And that is 15 multiplied by 8. What is 15 multiplied by 8?
120.
It's 120. Do you see you obtain the same answer when you are using the formula?
Yes.
Yes. But the formula is very specific, because with the formula, you can even be able to get the 100th term without any complication. But with this method, you are not going to get to the 100th term. Otherwise, there's a room for making a lot of mistakes if you use this approach there. Let me check the time. Okay, this meeting is going to log out. I want you to log into the second meeting. I will do example 2 for you, and then from there I give you example 3 for you to try. Okay, that's the question we have. But let's wait for this meeting to finish so that we get to the new meeting.